The DevOps Foundation Course, Lesson 8, DevOps Practices, the First Way.
Welcome to Lesson 8. In this lesson, we're going to introduce DevOps practices and then study the practices associated with the first way of DevOps. As you'll remember, the first way is all about understanding and improving flow. We'll be studying continuous integration, continuous delivery, continuous deployment, value stream mapping, Kanban, theory of constraints.
Our next study area is DevOps practices. These practices draw on Agile, Lean, and ITSM methods and techniques to bring the three ways of DevOps to life. Used correctly, DevOps practices should enable improved flow, improved feedback loops, continuous experimentation and learning. You will remember these from earlier lessons as the three ways of DevOps, described in the Phoenix Project by Gene Kim, Kevin Baer, and George Spafford. We'll study the practices that are used in each of the three ways. For your exam, you'll need to be able to identify which way a particular practice is associated with. Emerging trends based on recent studies show that DevOps practices are consistently found in high-performing organizations. Let's get started on the first way, understanding and improving flow. Before we can improve anything, we need to understand it. If not, how do we know where to focus our improvement efforts? High-performing organizations will typically have a good understanding of flow. They'll be able to provide documents such as value stream maps that demonstrate the flows that are important to the organization. In high-performing organizations with autonomous, empowered cultures, people and teams will self-organize to improve flow. This diagram shows a simple representation of the first way. Organizations need to understand the flow of work from dev to ops and should look for ways to increase flow. A goal of the first way is to have work flow quickly from left to right. Principles that support the first way will include never passing a known defect downstream, never allowing local optimization to cause local degradation, and achieving a profound understanding of the system associated with a flow. Many organizations do not understand their flow or how their organization fits together. Changes in one place can have adverse impacts in others, leading to a reduced level of flow. Earlier in the course, we mentioned some terms like continuous integration and continuous delivery. We're going to look at those in detail now, starting with continuous integration. Continuous integration is a development practice that requires developers to integrate code into a shared repository on a daily basis. Continuous integration is a first step towards building quality at the source. Multiple code branches are integrated into the trunk or master code, so that testing can be carried out and issues can be identified at an early stage. In a DevOps context, continuous integration must test on production-like environments, with test criteria addressing areas including acceptance and integration. Continuous integration involves checking in code at least once every 24 hours. The checked-in code is often referred to as a commit. Commits are then validated by an automated build and an automated set of unit, integration, and acceptance tests. Continuous integration helps to identify if a change will break a system at the earliest possible point, so defects aren't passed downstream. It also identifies what caused the break, allowing remediation to take place as quickly as possible. Integrating regularly into production-like environments makes it easier to quickly detect and locate conflicts and errors. Organizations that are using waterfall methodologies can still take advantage of continuous integration and test-driven development practices. The next concept we need to study is continuous delivery. This is a methodology that focuses on making sure software is always in a releasable state throughout the lifecycle. Continuous delivery extends continuous integration. It is achieved by continuously integrating software done by the development team, building executables, and running automated tests on those executables to detect problems. The executables are put into increasingly production-like staging environments to ensure the software will work in production. The benefits of continuous delivery include reduced risk, demonstrable progress, and quicker access to user feedback. An organization is doing continuous delivery when software is deployable throughout its lifecycle. Teams prioritize keeping software deployable over working on new features. Anyone can get fast, automated feedback on the production readiness of their systems when a change has been made to them. And it's possible to perform push-button deployments on any version of the software to any environment on demand. Continuous delivery is not the same as continuous deployment, which we'll study next. The terms are often confused. Continuous delivery means that we can do frequent deployments if we wish. While the software is ready in a staging environment, we might choose not to deploy for a variety of reasons. The business, for example, might prefer a slower rate of releases. The deployable code could be batched up into larger changes to be released at agreed intervals. The diagram on your screen shows the flow of continuous delivery. As soon as someone makes a change that causes the automated tests to fail, the deployment pipeline is broken and developers stop the line to bring the system back to a deployable state. Doing this throughout the development project removes the need for a testing and integration phase at the project end. Too often, testing and integration phases get skipped at the project end if the project is running out of time. This can lead to technical debt and reduced quality. Any errors discovered at the end of the project will take longer and be more expensive to fix than if they had been identified further upstream. Automated tests in production-like environments assure the code and environment operate as designed and are always in a deployable state. Deployment is the installation of a specific version of software to a given environment. For continuous delivery to be successful, we need monitoring throughout the deployment pipeline. Ideally, this will be automated. Monitoring needs to include all environments, from deployment to test to staging, and so on to production. Remember, catching problems early on will reduce the cost of fixing them and could also reduce their impact on the business. Continuous deployment is the next term we will study. This is not to be confused with continuous delivery. Continuous deployment is defined as the set of practices that enable every change that passes automated tests to be automatically deployed to production. Continuous delivery delivers code into a staging environment so that it could be released into production at any time. But this doesn't mean it has to be released. Continuous deployment means that every change that goes through the deployment pipeline is automatically released into production, creating a situation where there could be many deployments every day. Let's think about continuous deployment with an exercise. Plan to spend 15 minutes on this exercise. Continuous deployment removes the need for manual deployment. This can result in multiple deployments per day. This increased flow can deliver real business value. What are the benefits of continuous deployment? What sort of organizations would it be suitable for? Can you see any risk associated with continuous deployment? Are there any organizations that it would not be suitable for? Continuous deployment is an expression that can make some people nervous because they think of a release as a big bang, something that is highly visible and affects the whole organization. This isn't the case. Agile software development methods ensure that developers are constantly testing their code and getting feedback on it so that they can fix errors early on. Before code is made visible to end users, it is often deployed into the live environment, but in a way that means it is only visible to staff who are carrying out testing. This can be days, weeks, or even months before it's turned on for the end user. Even when the new feature is live, it doesn't have to hit all users at once. New features can be switched on in a controlled way, phasing through the organization to minimize risk. Have you ever seen a deployment go wrong? Could these techniques have prevented it? Here's a reminder of what continuous deployment looks like. Remember, continuous deployment doesn't mean customer overload. Release, in this context, means the process or event of making a feature or set of features available to a segment of customers. The majority of customers might not even be aware that there is continuous deployment taking place.
Think about the apps on your mobile phone. Many of them will be updated using continuous deployment processes, but as a user, you're often not aware. The apps from regulated environments, such as online banking if you have it, are the ones that are most likely to notify you when a change has been made.
So far in this lesson, we've studied some of the practices associated with the first way: continuous integration, continuous delivery, continuous deployment. Still to come, we'll study value stream mapping, Kanban, theory of constraints. Remember, it's important for you to understand these practices and which one of the three ways they're associated with. The DevOps reference card in your download area will be a valuable study aid, but don't forget the power of making your own notes too. Let's look at value stream mapping next. Value stream mapping is a lean tool that depicts the flow of information, materials, and work across functional silos, with an emphasis on quantifying waste, including time and quality. Value stream mapping helps organizations to analyze their current state and design a future state for the activities that take a product or service from its beginning through to the customer. Value stream maps are used to understand and streamline work processes using lean tools and techniques. Remember, we're talking about the first way: understanding and improving flow. Value stream mapping is a fantastic tool for this. Creating a value stream map provides an objective view of the organization, which can then be analyzed and improved. Cross-functional teams can see an entire process from end to end, helping them to understand areas that they might not otherwise be involved with on a daily basis. They can also view a service or product from an information flow perspective. The current state of the value stream can be analyzed to see if there are any opportunities to reduce wasted effort or time. Improvements can then be identified, prioritized, and measured, perhaps using the plan, do, check, act methodology we mentioned in early lessons. Why not do some research into value stream mapping? Our next area of study is Kanban. This might be something you've come across before, as it's gained popularity on both an organizational and a personal level. Kanban is a method of work that pulls the flow of work through a process at a manageable pace while reducing work in progress. Kanban is a pull system, allowing teams to pull work in only when they are ready for it, reducing overburden. Kanban is designed to reduce idle time and waste in a process. In Japanese, kan means visual and ban means card. Visual cards are used to trigger action, allowing teams to pull work when they are ready for it, and people to work collaboratively to improve flow. You can see an example of a Kanban board here. Click on To Do, In Progress, and Done to learn more. Kanban makes work visible. Teams can see what needs to be done and pull work when they have the capacity to do it. Work in progress, or WIP, needs to be limited to the capacity of the resources available. Too much WIP can lead to overburden. You might experience this yourself on a personal level. Some days there seems to be so much to do, it's hard to start anything. Kanban helps to visualize and manage workflow. Kanban can be used to measure velocity, the quantity of work completed in an iteration or sprint. Lead time and cycle time can be measured using the boards. Kanban doesn't have to be complex to implement. It can be as simple as sticky notes on a wall or a whiteboard. There are some supporting tools available for Kanban, some of which are free. Click on the links on screen to learn more. Do you use Kanban boards in your organization? Here's a short exercise to reinforce the importance of Kanban. Spend about 10 minutes considering this question. Kanban analyzes work in progress and identifies when there is too much. Why is too much work in progress a bad thing? What are the consequences? Our final topic in this lesson is the theory of constraints. The theory of constraints was introduced in The Goal, a business novel by Eliyahu M. Goldratt and Jeff Cox. Put simply, the theory of constraints recognizes that every process has a point that has the potential to be a bottleneck. To function more efficiently, organizations need to identify constraints and reduce the impact of the bottleneck or remove it completely. Not all constraints can be eliminated, but their effects can be reduced. For example, a regulatory requirement might be a constraint that cannot be completely eliminated. The theory of constraints is a methodology for identifying the most important limiting factor that stands in the way of achieving a goal, and then systematically improving that constraint until it is no longer the limiting factor. The theory of constraints recognizes that every process has at least one constraint that can affect its ability to meet its goal. The process is only as successful as its weakest link and can only operate to the capacity of its constraints. Improving constraints is the fastest and most efficient way to improve the entire process or system. The 5 focusing steps is a methodology for identifying and eliminating constraints. You can see it on screen now. You will need to be familiar with this for your exam. Remember, a constraint is a bottleneck. If an organization improves steps before the constraint, it will cause work to pile up at the bottleneck. If an organization improves steps after the constraint, they will be starved for work. Click on each step to learn a little more. Identify the constraint. It is critical to identify the constraint correctly. If the constraint is identified incorrectly, the following steps will target all resources at the wrong area. Think about some methods you could use to identify constraints in your organization. Exploit the constraint. This means making quick improvements using existing resources. Quick wins can often be implemented with little extra effort, delivering immediate benefits. For example, if a manual step in a process is carried out inconsistently, it may be a quick win to automate it. Subordinate the constraint. This step reviews all the other process activities to make sure that they support the needs of the constraint. If we use the example of a manual process step being applied inconsistently, this step could include looking at how the information is gathered to support the step. Creating a standard set of information that is delivered in the same template might help to reduce inconsistency. Elevate the constraint. If the constraint still exists, this step looks at what can be done to eliminate it. The work continues until the constraint is removed. This might require funding or resources. A constraint is considered broken when it has been eliminated. This doesn't, however, mean the process will now be perfect. It's likely there will be constraints elsewhere to turn our attention to. Remember, there may be some constraints that can't be fully eliminated, but they still need to be minimized. Prevent inertia. The 5 focusing steps is a continuous improvement cycle. Once an iteration of the process is complete, work starts again, identifying and addressing other bottlenecks. Here's a quote from Eliyahu Goldratt, author of The Goal. We should be looking at each local area and trying to trim it. We should be trying to optimize the whole system. Some resources have to have more capacity than others. The ones at the end of the line should have more than the ones at the beginning, sometimes a lot more. Think about this quote in the context of DevOps. In many organizations, projects are given funding up front for development resources. Ops is seen as a cost center, where costs need to be minimized. This doesn't make sense in the context of this quote and approach. DevOps is the progression of the software development lifecycle, or SDLC, from waterfall to agile to lean. DevOps leverages lean to remove waste, which can manifest as bottlenecks in environment creation, code deployment, test setup and run, overly tight architecture, development, product management. All these issues cost IT and the business time and money just to keep systems running. Can you see how you would apply the theory of constraints in your organization? Here's a quick quiz to help test your memory.
You've completed Lesson 8. DevOps practices the first way. We've studied continuous integration, continuous delivery, continuous deployment, value stream mapping, Kanban, and the theory of constraints. Remember, you'll need to understand each of these and the fact that they're associated with the first way.